So quickly moving on the topic motion. So we talk about our final velocity. Talk about as probably in the next class on this topic. I'm going to do well to explain these terms: velocity, rate of change of displacement, your speed, rate of change of distance, your acceleration, rate of change of velocity. Now, there's something I would love to quickly explain, which is retardation. Retardation is simply the negative of acceleration. For interesting purpose, retardation is the negative of acceleration. The major difference between retardation and acceleration is in acceleration, velocity is increasing. But in retardation, velocity is decreasing. So another name for your retardation is it can also be called deceleration. So while solving the questions, when you ask to calculate the deceleration, it's also the same thing as asking you to calculate the retardation. Just like your speed, it says speed. Speed equals distance over time. Distance over time. That's how we were able to come out having the unit. The one I gave the other time. It said speed is in what? Distance in meter. Time in seconds. Meter per seconds. Your velocity is the rate of change of displacement. That's why velocity formula now is displacement over time. Still, velocity is also measured in meter per second. Some people might be wondering that why is speed in meter per second, velocity also in meter per second? The major difference between speed and velocity is just their quantity. Speed is a scalar quantity. What is a scalar quantity? Those are quantities that has only magnitude but no direction. But your velocity has both magnitude and direction. So that's to tell you that your velocity has both magnitude and direction. So it is a vector quantity. So those are vector quantity. So another one to talk about here is your acceleration. Acceleration is the rate of change of velocity, meaning velocity change over time. Mind you, velocity itself is in meter per second. I'm not having time also too. So that's why here it is meter per second square. Then lastly, what are we having here also too? So quickly, you remember I said acceleration. In acceleration, there is an increase in velocity. But in retardation, there is a decrease in velocity. That's why retardation is just the what? The negative of your what? Your acceleration. So before we move into this topic, before we start solving questions, there are some things you need to note. And these are these. Note. When a body is starting from rest, I take that again. When a body is starting from rest, your initial velocity is 0. Meaning the body is at a particular position, it's not starting from rest. Take note, initial velocity is 0. But when the body is already in motion, it's now coming back to rest. Take note of the first one. A body starting from rest, initial velocity is 0. But a body is coming back to rest, final will be 0. So when the body is starting from rest and the initial velocity is 0, meaning the final will be greater than 0. But when the body is coming back to rest, the final will now be 0, meaning the initial now will be greater than 0 for reference purpose. Starting from rest. Coming back to rest.